Assalamualaikum students. Students, in this lecture, I'm going to explain buffer solution with you people. Most of the students find buffer a bit difficult, right? You know what is the reason? Because they don't understand that what actually buffer is. Like, what is a buffer? The substance, the solution. It's not just substance, it's solution. It must be aqueous solution. Buffers are aqueous solution that resist changes in pH. Like they don't let the pH to change. Even if H plus and OH are added in that solution. Like there is a solution, H plus is added. So if H plus is added, the concentration of H plus will increase. The pH should change. But if there is a buffer, the buffer will not let the pH to change. So what buffer will do? The buffer will react with H plus. The buffer will react OH. Like, look, in our blood, there is a buffer, therefore the pH is constant. The pH is not changing in the blood. Why? The pH of the blood is not changing. Why? Because blood contain buffer. Blood contain hydrogen carbonate. Blood contain amino acids, right? Proteins, they're all buffers. Amino and acid, there is a base, there is an acid in the same molecule. It's kind of amphoteric. So if you are taking some injection and they're directly they're intravenous, they directly enter into the blood. Like I'm not talking about the digestive gut, because in the digestive system there is HCl in the stomach, there are enzymes with certain alkaline medium in the small intestine. So they're passing through some quite different situation. I'm talking about direct something entering into the blood. If it is acidic, it will not change the pH of the blood. Even if it is alkaline, it will not change the pH of the blood. Why? Because in the blood, there are hydrogen carbonate, there are amino acids. They neutralize the incoming H plus and OH. They don't let them to change the pH. So, to explain buffer, I'm going to do all this on a separate page, right? You know what is buffer? If I define it. Buffer is solution that resist changes in pH if small amount of acid or base is added. Buffer maintain pH is incorrect. Buffer helps to maintain. So you have to make the statement flexible. Resist changes helps to maintain the pH. Like you're not supposed to say exactly that it stops changes in pH. No, it resists changes in pH because if you are adding too much of acid or base, the pH will change. Like buffer is for small accidental addition of H plus and OH, not for the deliberate act of adding a large amount of H plus or OH. No. So, buffer is something that can react with both acid and both bases. Buffer will neutralize this. Buffer will neutralize this. So what should be buffer then? Buffer could be amphoteric solution of amphoteric substances. mixture of weak acid and its salt. You know, its salt provide conjugate base. Salt provide what? This I'm going to explain. Conjugate base. And mixture of weak base and its salt. Now, I'm going to start with the amphoteric thing. Look. This is a solution. I'm explaining which substances? Amphoteric. Suppose there is this amino acid. This is amino. This is acid. You know, amino acid is containing amino group as well as acid group. It contains amino as well as acid. This amino can accept and this can donate H plus. It has lone pair, it can accept H plus, making dative bond. Now, what I'm going to do? Suppose this is your big container. I'm making a large container to explain. This contains the amino acid. And you know what happened? This solution has certain pH. What happens? It's a buffer solution. It is buffer. So H plus is added. Now tell me, if H plus is coming, would this pH remain the same or it should change? Definitely this pH should change because now the H plus is more. But if this H plus come and make a dative bond with H plus, do you think this H plus is any longer part of the solution? No, the pH is not going to change. H plus coming is going to make a dative bond with. It's going to make what? A dative bond with this. As a result, what will form? This H plus become bonded to this. It's no more part of the solution. Now, if in the same solution, it has certain pH, everything was balanced. OH accidentally come with the pipette. If the OH is coming here, the OH is going to change this pH of this whole solution because it's alkali. But if this OH is neutralized by this acid, it becomes water. Do you think the OH will change the pH of that solution? No. So the OH is neutralized by this. H plus is neutralized by this. So the amino acid in the blood will not let the H, the OH to change the pH of the blood. It remains the same. So how you write the reaction for OH? CHR So what will happen? This is base, this is acid, loses H plus to this. So what is formed? Water plus CO2 negative. If this is acid, this is what? Base. React. This is acid. Acid is not going to react with acid. This is base. So base is not going to react with the base. It is reacting with acid. Another thing. Usually in the paper they ask how the pH of the blood is maintained. pH of blood before surgery. Before surgery, pH of the blood is maintained by injection of HCO3 negative. Why? You know, this is amphoteric. Why? Because due to negative sign, it can accept H plus. And it can also donate H plus. So amphoteric. It can accept H plus, making H2CO3, giving H plus to OH, making what? CO3 dye negative. How you are supposed to write the equation? Hmm? So what is the behavior of this thing? With the acid, it becomes like a base, accept H plus. With a base, it becomes like an acid, donate H plus. So what is formed in the upper one? Accept H plus. Donate H plus, making what? H2O plus. CO3 to negative. This is a 3-mark question. So if I ask you that if there is H2PO4, do you think it's an amphoteric thing too? Think. Yes. Why? Because of the negative sign, it can accept H plus. And since it is having hydrogen, it can donate to OH. So if there is H plus with H2CO, H2PO4, sorry. It is acid, it will act as a base, it will accept it, making H3PO4 perfect. If there's OH negative, which is a base, with a base, the H2PO4 will behave like what? Acid, donate H plus, making what? Water. After losing H plus, when H is less, the negative charge will increase. And secondly, one thing that you must keep in mind, in any chemistry reaction, the charge of this side is equal to this side. So it is 0, minus and plus, it is also 0. Minus and minus, it's minus 2, and this is also what? Minus 2. See, 0, minus and plus is 0. It's minus 2, and this is also minus 2. Most of the students I've seen, they make mistake with these equations. Like they don't put the charges correctly. Now, after amphoteric things, the next is what? Mixture of weak acid and its salt. This is the most important part of the buffer. See? Mixture of weak acid and its salt. Right? Weak acid and its salt. Suppose this is the container. We are going to do this in detail because this is linked to the pH calculation too. The same concept. This is mixture of weak acid and its salt. Suppose the weak acid is ethanoic acid. It ionizes partially, producing what? CH3COO negative, right? And I'm using its salt. which is a strong electrolyte because group 1 salts, group 1 things are always strong electrolyte. It's covalent, it ionizes, it's ionic, it's already ions. So the proper terminology is that they dissolve, not ionize. So it's going to dissolve. I even sometimes used ionize, but it's actually dissolve, right? So it's what? I'm writing Na plus before. Na plus and CH3 COO negative, right? You can even write it the other way. Oh, what I did. What I'm doing. It's perfect. Leave it the same way. It's going to dissolve and it also ionizes H and this thing. So what you can see, it's a weak electrolyte. It's a strong electrolyte. This is weak acid. This is its salt. Right? Is there a common ion effect? Yes. There are many, many things we are going to do. This weak acid, you are going to dissolve, ionize. When it ionizes, it produces very less conjugate base. Like suppose it was 1,000, and out of 1,000, only 3 ionizes. 3. And this is 997. Like we have very large amount of the weak acid. But the conjugate base is very small. And for to be act as a buffer, we must have large excess of weak acid and large excess of its conjugate base. We must have large amount of these two. If I'm not adding this, if I remove this whole thing, if only weak acid is there in the solution, there is a lot of weak acid. The conjugate base is very less. If H plus is coming, the conjugate base is so small, it is not fully neutralized. It will not act as a buffer. Like see, if the weak acid is alone, it will produce conjugate base, but the amount of the conjugate base is very small. The weak acid is a large. To increase the conjugate base, what I did, I will add the salt. And what happened? It ionized completely. When it ionized completely, dissolved completely, there is a large concentration of the conjugate base. That is all coming from the salt. Suppose this was 1,000. It produces 1,000 and 1,000. It finished, dissolved. There is very huge amount of the conjugate base now. It will push the equilibrium to the left. The acid is almost unionized, and the conjugate base is almost all coming from the salt. So what is happening in your container? In your container, the final situation is this. The acid is almost unionized, and the conjugate base is all coming from salt and conjugate base. Because this is weak acid and this is conjugate base. They differ by 1 H plus. They differ by 1 hydrogen from each other. Any conjugate acid-base pair is the acid-base pair which differ by 1 H plus. So, listen. If in your container, now, the weak acid is present, unionized, the conjugate base is coming from the salt. Now, in this solution, if H plus come from outside, this H plus will change the pH of that whole solution? No. Why? Because this conjugate base will attract it toward itself and it will make a covalent bond with it. It's no more part of the solution. The pH will not change. And the equation would be this way. The H plus coming in the solution is now covalently bonded to O of the COOH. So it's not becoming part of the solution. If OH is coming from outside, the OH will change the pH, which will make the solution alkaline. But this OH is not allowed by weak acid, right? This weak acid will lose H plus, neutralized, making water this way. CH3COO negative and H2O. Right? Look. Another explanation, another example. I have a weak acid, nitrous acid. It ionized partially. This is very large, but this is very small. Right? Now, when you add NaNO2 to increase the NO2 negative, nitrite ion, the conjugate base. This is weak acid. This is its conjugate base. To increase the conjugate base, I'm adding salt. When I add the salt, it dissolves fully. When it dissolves fully, it will increase the concentration of the nitrite. As a result, what will happen? As a result, what will happen? The concentration increase. It shifts the equilibrium for this to the left-hand side. Now, what will happen? It is fully resolved. It is almost suppressed. And your beaker, this is suppressed. Your weak acid is almost unionized. It's not going to dissolve. And all the conjugate base is coming from the salt. So in the beaker, what are present? The acid is almost unionized. The acid is almost unionized. And the NO2 negative is coming from the salt. And Na plus also. Na plus is spectator. Na plus is spectator in the upper one. See? Na plus is not the part of the reaction. The H plus is neutralized by, the H plus is neutralized by the conjugate base. The OH negative is neutralized by the weak acid. The Na plus is spectator. In this one, exactly the same will occur. The H plus is neutralized by this. The OH negative added is neutralized by this. So now what you will do, if they ask you in paper this way, like in the paper they will ask the question this way, that you have ethanoic acid and sodium ethanoate. Write down two equations that how it acts as a buffer. So what is your first step? You must know that this is your weak acid. This is your salt. The Na plus is spectator. It has nothing to do. So H plus is going to react with the conjugate base making CH3, COOH. The OH negative is going to react with weak acid, making what? CH3, COO negative and water. Now, if they ask you, so this is your full-fledged answer. If they ask you that you have HNO2 and NaNO2. So what you are supposed to do? Cancel the spectator. This is your weak acid. This is your conjugate base. And H plus will react with the conjugate base, accepting it no more part of the solution, the H plus. And the OH will be neutralized by HNO2, which will give H plus, making it water and NO2 negative. Right? Now, if in the paper they ask you that you have HOCO, CH2, CH2, COO negative. This is a buffer. How it will act as a buffer? You know the Na spectator. Cancel it. This is weak acid part. This is the conjugate base part. Yes, this thing can act as a buffer. Why? Because if H plus is added into that solution, it's going to react with what? See? The conjugate base part will combine and the will combine with what? With H2, with H plus. And it is unionized acid. And if OH is there, so these are all the questions from your past papers. Keep in mind, the examples that I explain are in your past papers, right? So focus on this so that you can do the past papers swiftly. It will lose H plus, making H2O, O negative, CO, CH2, CH2, and CO negative. Clear? Now, if I ask you, that is ammonia and ammonium chloride a buffer? Yes. And this chloride is a spectator. Ammonia is the weak base and ammonium is conjugate acid. So if H plus is added, it's going to react with the weak base and ammonia will accept the proton making ammonium, not changing the pH by the H plus. If OH is added, it's going to combine with ammonium and it will lose H plus to OH, making water and ammonia. Right? So I hope you understand how to write the equation that shows that how the H plus and the OH are neutralized by the buffer. Now, your next topic is how to calculate pH. How to calculate pH of the buffer, and secondly, how to make a buffer. How you'll make a buffer in the lab. Look, you want to make a buffer, prepare a buffer in lab. There are two methods. Either go in the lab, take a beaker, take weak acid, and put salt. Mix weak acid and salt. Mix weak acid and its salt. Mix weak acid and its salt to make what? Buffer. You can mix any amount, and you will get buffer of your desired pH. But for that, you must know how to calculate the pH. But first thing, can you mix any amounts? Yes. You can make buffer of your own desired pH. And there is another method. What you can do? Now listen carefully. Suppose, you know what I did? I am in the lab. I don't have the salt. Suppose I have weak acid. I don't have salt. So what I will do? I will add a strong base. Right? Now, suppose I will use excess weak acid. Keep in mind. Why? I'm telling you it. Suppose there are 10 molecules. And I'm deliberately adding 4 molecules. This is acid, this is base, they're going to react. Yes. The 4 base will react with 4 acid. How much salt is formed? 4. 4 salt formed. All the base finished. What is there in your container? What is there in your container? 6 weak acids plus 4 salt. Is this weak acid and its salt? Is this a buffer? Yes. So how can you make a buffer? Either by mixing weak acid and its salt or add excess weak acid to strong base. So there are 2 methods to prepare buffer. Mix weak acid and salt. And what is the second method? Add excess weak acid to strong base. Add excess weak acid to strong base. Now, when you do questions of pH calculation, you find that some are by one method and some are by the other method. Actually, you people don't differentiate that are they giving you in the question the weak acid and its salt, or they are using weak acid and its salt. Like you don't understand that what is the given situation. So first thing, how you will calculate the pH, and then I'm going to relate this with this. How you will calculate the pH of the buffer. pH of buffer. We use this formula. H plus is equal to Ka into weak acid over salt. There is another formula too that I'm going to explain after explanation of this. Like I'm going to relate. They're the same thing. There is no difference. In that we use pH is equal to pKa plus log of salt over acid. Both are equally salt over acid. Correct. But I personally use this one more. Why? I'm going to explain it. But from where we get this formula? First, listen. This was your HNO2. That was ionized partially. Agree. The K value is, the K expression is H plus HNO2. Now listen. Would the K changes by adding NaNO2? Not at all. The K is only changed when the temperature will change. So temperature is not changing. If temperature is not changing, the K will not change. Yes, these values will change, but K remains the same. So when you are adding NaNO2, what will happen? Common ion effect. So, common ion effect. The concentration of this will increase. This is all the salt is dissolved. All the salt is dissolved. This equilibrium shift to the left hand side. It's almost unionized. So we are going to put this value here, unionized, the initial, and all the conjugate base is coming from salt. So instead of this, I put the concentration of salt. Look, all this is coming from salt. All the acid is almost unionized. So what I did, see, Ka is equal to H plus. Instead of this, I'm writing what? Salt. And this is what? Weak acid. If I make it subject, it will change to what? Ka into weak acid over salt is equal to what? H plus. So if I know the concentration of weak acid and salt and Ka, can I get the pH plus? Yes. Like I know the K value, what I told you. K into weak acid over salt. I can get the pH. H plus is equal to what? Ka into weak acid over salt. Now, I can get the pH directly by taking negative log of H plus. That's it. But if you want to use the other formula, what you are supposed to do, take the negative log of H plus, negative log of Ka, negative log of weak acid over salt. Negative log of H plus pH, pKa, and negative log of weak acid over salt. How can you change this to positive? For this, you have to switch these. So pH is equal to pKa plus, what I did, log of salt over weak acid. I personally don't use this much. I use this one more. This, right? Now, in the next lecture, I'm going to relate this to the buffer preparation and their questions. See, we are going to do these questions in detail. Look. So that you differentiate. Like why you people find buffer difficult. Buffer is a very easy topic. Right? These are the questions. Wait, I'm showing to you. From 42 till 63. Like we will do some question and I'm 100% sure that you would be able to do all. Right? pH, when excess weak acid is added to strong base, how you will deal. And then the second part is what? Mixed weak acid and salt. This is quite easy, this one. The other part, the A part, they're a bit tricky. And this is like, you can see, you know the concentration of tartaric acid, you know the concentration of sodium tartrate, you know the K value. So what is H plus? Ka into what? Weak acid over salt. You get H plus. And then what is the pH? Take the negative log of the H plus, you get the pH. But we are going to do some questions so that you people understand that buffer is a very interesting topic, a very easy topic of chemistry. And अगले लेक्चर के लिए तक के लिए आपसे इजाजत. Don't forget to like, subscribe, and share my channel. Okay, Allah Hafiz.